All right, so I've set up ourselves for the next case, the fifth case over here, where we want to add our fifth item, or we want to add in an item anywhere else. We want to add this item to index I. So no need to debate this as much as we did for the first time around. We know what we want to, especially if we want to make this reflective of what we've already done. So we're going to go ahead and still be getting node I minus 1. If I want to put this node at index I, that means I need to put it right here so that this will be I minus 1 I, then this will become I plus 1, and this will become I plus 2. And if I want to do that, I'm still going to get this guy that's before the index I want to insert at, just because I want to keep it very similar to what we've already done. So we'll say before is equal to, or node before what I want the index, the node that's before index I and what we want to be before adding. So it's a pretty good name for it. Not new node, but get node, which again works exactly the same. Index minus 1. Get node index minus 1. Okay, so that gets before. And so now what do we have to do? We want to connect adding over here so that it points together. Or sorry, that we get that it's connected so that next is I and its previous is I minus 1. So actually, let's go ahead and do that. The first thing we should, and I don't need 4 of these guys, I just need 2. So the first thing I should do is, like I said, first thing I want to do is if I'm adding a new node, I'm going to go ahead and hook it up. So I need to hook it up to .next to be here, and his .previous, oops, connecting it to the wrong thing, .previous to be here. So again, let's take that one step at a time. So let's ignore the .next for now. First thing I want to do is say adding .next is equal to, and just like we would do in the regular linked list, we're going to do before .next. Right? Adding's .next is equal to before's .next. So we're going to copy that memory location over so that adding ends up pointing to that over there. Next, we need what needs to be the previous thing for adding. It needs to be before. So adding .prev is equal to before. Now, despite having twice as many moves I need to make as a singly linked list, it's actually a lot more safe to do this because I can move basically these guys. It's a lot more forgiving the order you do these in. All right, so in order to compensate for this, right, I've connected adding in, but he hasn't been integrated into the list as full. Before's .next needs to be adding, and adding's and this guy needs to and the guy at index I needs to point to adding. So it doesn't matter which one we do first, because all that will just simply change what happens the next time around, or for the next move. So let's go ahead and move this pointer first to point to this guy. So how do we do that? We want to connect this pointer to him. It's currently pointing over here, by the way. So what is this pointer? It is before's .next's .prev pointer. Another way to look at it, though, is that it's also adding's .next .prev. So before .next .prevs, right? It seems like that should be be referring back to before. That's just currently the variable that is holding before, right? Before.next.prev is currently holding before. .next. This is currently pointing there. But now we're saying instead I want to save in there before.next.prev should be adding to connect it in. And this connects over to here. Okay, and now finally, before.next should now connect to adding. Whoops. Right. There we go. And so now adding's been fully integrated into this list. So now this will be I, this will be I plus 1, this will be I plus 2. It's a fairly straightforward thing. And again, if and we don't have to worry about the other cases of like, what if we're adding to the tail? Because guess what? We just programmed that in. So that's great. So next we will tackle the remove method.